Hi everyone, today we are discussing about verification of Faraday's law. Faraday's law means time varying magnetic field produces electrical field. So, from that Faraday's law, here you have to find out to determine the magnetic flux induced by falling magnet as a function of the velocity of the magnet using induced EMF. Corresponding operators are glass tube, photo gate. So, the use of the photo gate is to detect the speed of the magnet. Photo gate is connected to digital timer. This digital timer is connected to, this is a chargeable digital timer, that is why it is connected to a charger. So, when we see this digital timer, initially it shows time, we need to find out speed, go through, press here mode. So, we got speed. Next in speed, this is one gate, go to select and press it, 2 gate, collision up to the mask, press up to the mask. Once you got the mask, press start or stop, it shows magnet length. So, again press start or stop, press up arrow, again start or stop. Now, our photo gate is ready to detect the speed of the magnet. Keep a sight. Later on, we have a circular coil. So, in the circular coil, the circular coil consisting of dia, length, turns. So, this is diameter of the circular coil, this is the length of the circular coil, and this is T. T means turns, number of turns in the coil is 1150. Later on, this circular coil is connected to a voltage sensor. This is the heart of the experiment. This is it connected to a voltage sensor. Voltage sensor connected to a data logger. Voltage sensor connected to a data logger. Data logger is connected to monitor. Data logger is connected to a monitor, and we have a software MI lab software and cylindrical magnet. These are all operators. Our formula here you have to find the magnetic flux. Magnetic flux pi is equal to minus 1 by n into area. So, here we got the peak, here we got the graph between voltage and time. So, from that graph we got a peak. So, we divide this peak into two parts, first part is F1 and the second part is F2. When we add those two parts F1 plus F2, that is our area. So, our formula is magnetic flux pi is equal to minus 1 by n. So, modulus of minus 1 by n, capital N into area. Here n is equal to number of turns in the coil. We know the number of turns is 1150. So, what you have to find out? We have to find out the area. Procedure. Now, we will see how we will find out the area with the help of that MI lab software. So, first start the software, MI lab software. Open it. So, it shows logger has not been detected. So, why? Because here green light is glowing on. Press the switch 2 or 3 seconds, then automatically it is connected. So, now we will check, there is a dialog box left side of the screen. It shows UV, temperature, pressure, humidity, light, heart rate, voltage. So, we need voltage, that is why we click settings of, these are the settings of the voltage, click settings of the voltage. So, in those settings of the voltage, initial sampling, two modes are there, auto and manual, keep it in auto mode. Next rate, here we will take 1000 samples per second, it is a constant. Later on samples, according to your wish, we will take the samples. If we increase the samples, duration will increase. If we decrease the samples, duration will decrease. So, once again please check it. Here I took 200 samples, duration is 0.2 seconds. Here I took samples 200, the duration is 0.2 seconds. Here I increase the samples to 5000, the duration is 5 seconds. So, I took 1000 samples, that means 1 second. On x axis we have taken time. So, this is a start bar of to start the experiment. Keep your left hand on the mouse, keep your right hand on glass tube. So, please be ready with your cylindrical magnet, to pass through the glass tube. Glass tube will guide the magnet, it's exactly pass through the circular coil. So, start the software first. Initially we start the software, we release the magnet and catch the magnet after passing the coil. So, keep your magnet here, this is the peak, this is the positive peak and this is the negative peak. Now, here this is the first cursor and this is the second cursor, keep your first cursor here. Now, I am find out F1, this positive peak I will take it as F1, this negative peak I will take it as F2. So, I keep the cursors exactly. Now, I will find out the area. This is the positive peak area, area is equal to 0.026. This is the area of positive peak 0.026. So, write down the area, or if you want to take a screenshot, take it, F1 Windows print screen and close it. Positive peak area is over. Then this is the negative peak, that is the negative peak area. Again, if you want to take a screenshot, F1 Windows print screen. Those two areas were taken. I have discussed magnetic flux pi is equal to modulus of minus 1 by capital N into area. So, I already told the time of demonstration of formula, I told area is equal to F1 plus F2. F1 means positive peak area, F2 means negative peak area. We will add those two, and we will write area is equal to F1, area is equal to F1 plus F2. We got the area. So, we will substitute our those two area in our formula, magnetic flux pi is equal to modulus of minus 1 by N, N is equal to 1150 and area is equal to F1 plus F2. We will substitute those two values in our formula, then we got magnetic flux pi is equal to dash Webers. Thank you.